Hello and welcome to lesson 1.2 on finite and infinite number sets. Today's objective is that we will sort sets of numbers as finite or infinite and justify that sort. So really we're going to be looking at a given number set and determining whether it's a finite set of numbers or an infinite set of numbers. To begin with, we have some definitions we'd like to discuss. First one being the word terminal, which means to end or stop. An example of a terminal number would be 0.25. It's a terminating decimal because it ends. Non-example is 0.3. This bar over the top of it means that it is repeating. It will continue on, so I could write it as 3, 3, 3, dot, dot, dot. You might remember the dot, dot, dot from the previous lesson, meaning that it continues on forever. This is an example of a non-terminating decimal. Repeating, to continue forever, a pattern that continues. Some examples of repeating decimals are 0.333 repeating the dot, dot, dot. 0.1 with the bar over would just be 1, 1, 1, 1, 1. And 0.83 with just the bar over the 3, meaning that just the 3 continues repeating. Some non-examples of repeating decimals would be something like 3.14159 dot dot dot. The dot 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 means that it does continue, it's non-terminating, however there's nothing that repeats. This number might look familiar to you. It is also commonly referred to as pi. A set is a list of numbers. We use these braces to help us contain the set. Our set of numbers will always be contained within a set of braces like that. An example would be -3, -2, -1, 0, 1, 2, 3. This is the set of integers. You notice it has a dot, dot, dot on both ends, meaning that it continues in both this to the left with all the negative numbers, but also to the right with all the positive integers. We have some special symbols also that we need to know, some notation. So when we see this symbol, this brace, we say the words the set of the integers, the set of whole numbers. We have this colon here, such as, so as an example, such as, and this E symbol means it belongs to or is an element of. So we might also include that, meaning an element of. So a number, for example, 0 belongs to the set of whole numbers, or 0 is an element of the set of whole numbers. We use this notation in our set notation. You'll be seeing these symbols later in the lesson. So, finite versus infinite. Is knowledge something that's infinite or finite? Think about this for a moment. Why or why not? So is knowledge something that is continuous, it never ends, it continues on forever and ever? Or can it be contained? Is it a set? A certain amount? I'll let you be the judge. So the word finite means having bounds, a set that contains a countable number of elements, countable being the key word there. It also starts and stops. So there's a definite starting spot and ending spot. So some examples. We're really going to be looking at examples and non-examples today in most of our definitions. It's clear to see. An example might be the number set, the set of 2, 4, 6, 8, 10. Is that countable? Sure, there are 5 elements in that set. Does it have a start and a stop? Yes, it starts at 2 and ends at 10. Another example, -6, -5, -4, dot, 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 8. you might, if I wanted to write out this whole set, I might also include -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and 7. You can see the dot dot dot. If you notice the pattern, the dot 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 just fills in very nicely with that pattern. Is it countable? Yes, I could count how many elements there are. Does it have a starting spot and an ending spot? Most definitely. Days of the year in which the sun shines. This number can range from year to year. I believe typically here in Arizona, that number is close to 300 days in which the sun is shining, if not more. So is that a countable set? Yes, I can count the number of days the sun shines. It's a large number of days, but I can still count it. And does it have a starting and stopping? Well, if I was looking over a period of time, this year, last year, the last 10 years, I could definitely count that set for sure. Some non-examples would be here. Let's start with this one. Dot, 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 -3, -2. You'll notice this is a set of integers. That is it countable? No, there are infinitely many. There's no starting or ending spot. The even numbers. The even numbers would start at 2, 4, 6, 8, but where does it end? It has no stopping point. -20, there's my start, but do I have an ending? No, I have the dot, 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 meaning it goes on forever. And once again, I see that dot, 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 meaning that it just is going to continue on downward towards the left on what would be a typical number line, meaning that 0, -1, -2, -3, and so on would be there. It has this ending point of 4, so it has a stopping point, but it has no starting point. One thing that's jumping out at me as I'm looking at these sets, they may have the dot, dot, dot in them, meaning etc., but it is not at the beginning or the end of any set. Here I notice that those are either at the beginning or the end. At this time, I'd like for you to write down 2 sets of finite numbers and 2 real-life examples of finite numbers. I'll give you a few seconds to do that. You may want to pause the slideshow at this time. So there are many examples that you could write down as far as a set of finite numbers. What I'm looking for here is that you have the braces and that your set has a definite starting point and an ending point. Another example that you might include might be something like -13. Typically, our sets are written in order from least to greatest just to help us order things, but they don't have to be. So we might have a set that looks like this. 4.2 might be in there, and 1013. But it definitely has a starting point and an ending point. Some real-life examples of finite numbers would be anything that you could count. The number of shoes in your closet, the number of legs that are in your house, the number of fingers on your hand, etc. You could write many lists. Now, if I look at infinite, this is really just the opposite definition of what we just talked about with finite. It is a set in which the number of elements cannot be counted or determined. It's never ending. The set can continue forever in the beginning or the end or both. Looking at some examples, bring up those same examples we just looked at in the non-examples category. We have the dot dot dots, we have the even numbers, it continues to infinity. This pattern of -20, -10, 0, 10, 20, 40, or 10, 20, 30, 40, 50, it's going to continue forever. And same here, it's going to go in this direction forever. Some non-examples, anything with a starting and an ending point. For example, these sets of numbers here. At this time, I'd like for you to write down 2 sets of infinite numbers and 2 real-life examples of infinite numbers. I'll give you a few seconds. You may want to pause the slideshow. As I think about 2 sets of infinite numbers, basically I'm looking once again that you include the braces. There is no definite starting point, but I have my pattern. I might put in, if these are going up by 4, so -3, 1. I might have 5, 9, and put my end brace. I can have a start or a stop, but not both. I might also include something I know about, which would be from our last lesson, the real numbers. I know that the set of real numbers is infinitely large, since any and all number can fit in there. If I can think of a number, you think of a number, I can think of one smaller or larger than that number. Some real life examples of infinite numbers might be the number of stars in the sky. Is that countable set of numbers? Is it not? This would be many examples of our sets of numbers would be all fall in here, etc. So we want to determine, is the given set infinite or finite? The odd numbers. So if I'm on my number line, my odd numbers might start at 1, 3, 5. Remember, the odd numbers are any number not divisible by 2. Evenly divisible by 2, I should say. 9, 11, and this is going to keep going. My number line will be filled up. Is this infinite or finite? And it is infinite. Finite or infinite, and justify why. The given set, -2, -1, 0, 1, and 2, has a starting point and an ending point. I can count how many elements. There's 1, 2, 3, 4, 5 elements. Therefore, it is finite. Try this set, please. Finite or infinite, and why? Hopefully you said that it was finite because it has both a starting point and an ending point. Even though this ... is in there, it just means it's going to continue with the pattern of 7, 8, 9, 10, 11, 12, 13, 14, all the way to 15. Finite or infinite? Hopefully you said this set was an infinite set. This ... means that the set will be continuing in that direction forever, not ending. Some more symbols that we need to be familiar with. This symbol is greater than. When we're graphing on a number line, we use an open dot, and is greater than or equal to when you add the little line underneath it, the half of that equal sign. We use a closed dot when we're working on our number line. So we used this to compare the values of numbers. The biggest value is usually written on the left, and the smaller is usually written on the right, or always in this case written on the right. So to read this, I read this as 7 is greater than 2. -5 is greater than -12. And x, some number, is greater than 3. There are lots of numbers and solutions to this that I could plug in.